Intermediate Algebra, Section 5.3, Common Factors. Factoring is the reverse of multiplying. When factoring a polynomial, we always look for a factor common to every term. If one exists, then we use the distributive law to write an equivalent product. It is standard practice to factor out the largest or greatest common factor so that the resulting polynomial factor cannot be factored any further. The greatest common factor or GCF is the largest term that is a factor of all terms in the polynomial. And let's take a look at some examples here. They're asking us to factor out the greatest common factor of this first polynomial, 10x plus 8. You can think of this when you're reducing fractions. Very similar. We're looking for the largest number, which could include a variable common to both of these terms. Each are even, so there's a factor of 2. And if you write it as a factor of 2 or a product of 2 and the other factor that gives you the number, we can look at the remaining factors in each of these terms and see that nothing is common. So our greatest factor is 2. You're going to factor out a 2, which is code word for division, whether you write what you're dividing by or just mentally do the division, your choice, but just illustrate what's going on. I'm going to write it. 10x divided by 2 leaves us with a 5x, and 8 divided by 2 leaves us 4. Two things you want to check is look at the quantity in the parenthesis to make sure that your greatest common factor is 1 at this point, that you have factored out the greatest common factor. And between 5x and 4, we only have 1 common. The second thing you want to check is do your distributive property, multiply these back together to ensure that this is equivalent to the original expression. So if we take 2 times 5x, we get 10x, 2 times 4, we get a positive 8. In the next problem, greatest common factor, they both share an x, and when you have a common variable, the greatest common factor is the lowest power common to each one of them. So we can only go to x to the first power, and they each have a y. So greatest common factor is xy. Dividing each term or factoring out the common term leaves us with xy over xy, which is equal to 1 for the first term. In the second term, nothing is altering the 5, x to the second over x to the first. If you use your exponential rules when you're dividing common bases, you will subtract exponents, leaving an x to the first power, and y over y cancels out, leaving a 1, which isn't going to change our 5x. Inside the parenthesis, there's nothing common other than 1. A quick multiplication using distributive property verifies we have an equivalent expression. In this next trinomial, we're looking for a greatest common factor. The numerical portion of this, all are even numbers, and if we are breaking it down into 2 times the remaining factors so that we can determine if we can go any higher than 2. When we look at 9, factors of 9 are 3. They are not part of the 4, so we can stop right there. It has to be common to all 3 terms, so numerically 2 is the greatest common factor. They each share an x, and the lowest power common to each is to the third. Each term shares a y, and the lowest power is to the 6th. And each term shares a z, and the lowest common power is to the 4th power. Each of these terms then will be factored out by 2x to the 3rd, y to the 6th, z to the 4th. And I'll write that quickly here to show what we are factoring out. Factoring again is division. So 18 divided by 2 is 9. Common bases. Divided. Subtract your exponent, leaving us with an x. Y to the 9th divided by y to the 6th. 9 minus 6 leaves a y to the 3rd. Z to the 5th over z to the 4th leaves a z. A negative divided by a positive is negative. 8 divided by 2 is 4. The x to the thirds cancel out. Y to the 7th over y to the 6th leaves a y, and the z to the 4th cancel out, leaving a 1. Next, we have a positive 24 divided by 2 is 12. Common bases with our x. Subtract the exponential powers, leaves x to the 3rd. Y to the 6th cancel one another out, leaving a 1, and a z to the 5th over z to the 4th is a z. Looking here for anything common, numerically there isn't, variable-wise there isn't either, and then again a quick check with your distributive to see that that does in fact multiply to give us an equivalence to the original trinomial that we started out with. This next part is asking us to factor out a greatest common factor, but to factor out also a negative coefficient. This is a skill that we will use further in our factoring. So temporarily I'm going to ignore the negative requirement here and just look between the two terms. The greatest common factor is 3. Now consider factoring out a negative coefficient. So we'll put in -1 times our 3 or a -3. Factoring is dividing each term by -3. What happens sign-wise, -3 over -3 cancels one another out, leaving a positive 1 times x or just x. A positive 15 divided by -3 is a -5. Same rules apply no matter what we're factoring out. Inside, we look to see if there's anything common other than 1, and there isn't. Distributively, we'll have a -3x, a -3 times a -5 gives us a 15. And what we can make note of is looking at this leftover or this reduced polynomial here, these signs are exactly opposite of what they started out as. We had a negative, we now have a positive. We had a positive, we now have a negative, which again is a significant kind of trick when it comes to factoring polynomials that aren't quite in the form that we want them to be. Another example that they're asking us to factor out a negative coefficient. First of all, let's find the greatest common factor. They're all even, but we can also go up a step higher with 4. We'll do the negative while we're at it. Variable-wise, they all have x. The lowest common factor is x to the 1st power. The first two terms have y, but because the third term doesn't, we have to stop with -4x. Dividing each term then by the greatest common factor and the negative coefficient to boot means we're dividing each by -4x. Negative divided by negative is positive. 8 divided by 4 is 2. Our x to the 2nd divided by x to the 1st, subtracting exponents leaves an x, and we did nothing to the y. A negative divided by a negative is positive. 12 divided by 4 is 3. X's cancel out, leaving a 1 and a y, leaving a 3y for final answer. And positive divided by a negative is a negative. Same quantity over same quantity is equal to 1. It doesn't disappear into a 0. It's a 1. And we need to have it there so that when you do the distributive property, we generate that original or the last term in the original polynomial that we had. Quick checks on our factoring. Greatest common factor should be 1 if we factored completely, and it is. If it isn't, just factor again and put that additional quantity out in front. Next, your distributive multiplying through should give you the product from your original polynomial. And again, just a little note, by factoring out a negative, each one of our reduced terms is the opposite sign of what it originally came in as. The first one was negative, it's now positive, same with the second one, and the third term was a plus, and it's now a negative.